Okay, cool. So thank you all for joining us. Whoa, it's loud. Yeah, it's good? Okay. Thank you for joining us for this session. My name is Shaked, and I'm from the product marketing team at Wiz. And today we'll talk about securing your cloud and your AI development. Let me get the clicker. Okay, cool. So obviously we all know that it's very important to secure a cloud environment, but why is it so important to start securing it from the development and the software pipeline? So we're seeing more and more new attack vectors that start at the software pipeline that then lead attackers to your cloud environment. So a common attack path that we're seeing is vulnerable third-party code bases that then get deployed on a cloud resource that then an attacker finds and is able to use that to move laterally in the cloud environment and reach the crown jewels. And you can see examples of some recent attacks from the past few years. So because of that, in order to detect these types of risks, it's really important to understand the code-to-cloud correlation. So I'll give another example of an attack path that was discovered by the Wiz research team. So the research team found 38 terabytes that were accidentally exposed that belonged to Microsoft AI research team. Now, that all those 38 terabytes contain sensitive information like passwords, keys, secrets that were exposed through a GitHub repository. So the attack path that was discovered by the team was we first found this GitHub repository that was used by the Microsoft AI team in order to share open source models and share training data. So within that GitHub repository that was exposed, they were using a SAS token in order to share that data in their storage account. So with SAS tokens, they can be specific access to specific files, but they accidentally shared the entire account that had 38 terabytes. Now, not only was sensitive, it was even employee-specific information, so like employees' backups and Teams messages and so on. So why is it so important to be able to protect against these types of risks? So in this example, we can see that the risk originated within the GitHub repository. So if we're just looking at the cloud environment, we might not know and understand that it's actually exposed through our GitHub repository. So with that in mind, we realize that a lot of legacy approaches fall short when it comes to detecting these types of risks. So why is that? We have the traditional AppSec solutions, and we have open source tools that scan the code and detect risks. However, those types of tools don't have the context into the cloud environment. So let's say there is a secret that was found within the GitHub repository. Those traditional tools won't understand what that secret can do within the cloud environment, for example. And on the other hand, traditional tools like CSPM that just look at your cloud environment can tell you, for example, hey, you have an unencrypted bucket here, but they have no additional context as to are there any risks that exist in the code that could lead someone to that data. Okay, so with that in mind, we think organizations need to adopt a new DevSecOps approach that is really built for the cloud. And what does this approach look like? How can we detect these types of attack paths that start in our code and lead to the cloud environment? So there's 3 components here. One, we want to understand our code and pipeline security posture. So we want to understand how is my pipeline configured? Is it configured securely? Are there any risks around my pipeline or within my repositories? Then we also want to understand what are the risks from code to cloud. So we need to understand, are there any risks in my code? Are there vulnerabilities in my code? Are there any misconfigurations in my ISC templates? As well as scan the code to look for exposed data, or exposed sensitive data and exposed secrets. So now that I understood the risks in my code and I understood the security posture of my pipeline, I need to bring all of that back to my cloud context in order to really understand how can an attacker use that information in order to reach my cloud environment. So with that on the 3rd bullet here, it's very important to have agentless and sensor context so we can truly understand the risks in the code and what they mean in our cloud environment. And with that, we also need to understand what are the attack paths that can be originated from the code, lead to our cloud environment, and do any of them manifest in runtime? Okay, so as a DevSecOps approach, we have 2 goals. Our first goal is to remediate risks fast. And the second one is to be able to maintain a good security posture or maintain what we call zero critical issues, where you reduce all the critical issues in your environment. So how do we achieve these two goals? The first step is obviously we need to detect the risks in our environment. So how do we detect them? We need to understand, first of all, the code to cloud and cloud to code correlation. So if I have a risk in my cloud environment, but that risk is originated in my code, I need to understand what is the relationship between my cloud environment and my code, so I can see what is the root cause of that risk and if it is in my code. And I can also determine the ownership to understand which developer is responsible for that piece of code. I also want, again, to understand the security around my pipelines. So are there any misconfigurations in my VCS, my CI/CD pipelines, and artifacts registries? And I also want to detect the risks within my code, so detect those vulnerabilities, misconfigurations, secrets, and sensitive data in my code. So having these three in place help me understand the root cause and what are the risks in my environment. So now that I understand the risks, I want to be able to remediate fast. So how do I remediate? The most critical piece here is that I want to be able to prioritize the critical risks with context. So there might be a vulnerability that I find in my repository, but it's not actually deployed or loaded into memory into any of the servers in my environment. So that is why it's so important to have that context of my cloud environment and my runtime, so I can understand which risks are actually critical. And we also want to be able to empower developers with the context and guidance so they can be the ones to remediate the risks. So we want to make it very easy for them to understand risks. So lastly, once I was able to detect the critical risks, remediate them, now I want to maintain my good security posture long term and learn from what I've learned in my cloud environment to prevent risks from ever getting deployed. So I want to be able to shift left and use the guardrails that I've used in my cloud environment, shift them left to detect them in my software development lifecycle. So when you're looking for kind of shopping for a solution that can help you achieve all of those goals, these are the key capabilities that you want to make sure that it has, and we'll also show an example of each one of these. But the first one is we want to have that cloud to code visibility. So a resource in my cloud, where does it originate in my code? Next, you want to have a unified policy engine that expands from your code to your cloud environment to runtime, so you can detect risks across all those three with consistent policies. So next up, you want to have context-driven remediation. So if there's a risk in your environment, you need to understand the context around it so you know how to remediate it, prioritize it, and provide that context to developers as well. That tool needs to enable you to be able to shift left so you can move those guardrails into your development lifecycle. Also needs to help you to detect those misconfigurations and risks around your pipeline. And last but not least, which we'll touch afterwards, is the ability to remove AI pipeline risks, because AI is such a big part of development these days. So I'll quickly go over each one of these. So starting off with the cloud to code lineage. So as I mentioned, it's obviously important to understand what is the relationship between my cloud resources and my code. So we want to be able to map the environment from the cloud to the code to be able to understand that complexity. So then we can remove risks if they do come up. And we also need to determine the ownership of, hey, this resource in my cloud environment was created in this piece of code that is owned by this developer, because then it will help us with remediation. Next up, we need to have that unified policy engine that expands from my code to my cloud to my runtime. And for that policy engine, we need to make sure that we're able to detect vulnerabilities across all three of these, detect any secrets, any exposed secrets, sensitive data, look at misconfigurations, and so on. So we want to be able to use the same policies across the lifecycle. Okay, so this is one of the most important pieces, is that we need to be able to prioritize the critical risks. So really quick, for those who are not familiar with Wiz, we run risk assessment, and then we map every risk we find on the Wiz security graph that you see here. And the reason we do that is that it allows us to detect attack paths in the environment. So rather than just having a vulnerability finding, we tell customers, hey, there's a machine that's vulnerable, but it's also exposed to the internet. It also has access to this bucket that has sensitive data. So essentially, this is the core of prioritization and helping organizations focus on the critical risks versus the noise. So it's important to be able to prioritize those attack paths in order to reduce risk that actually has impact on the environment. So for the shift left aspect of things, we want to make sure that we can deploy the guardrails with the tools that our developers use. So we want to be able to detect misconfigurations, vulnerabilities, expose secrets within the developer IDE, on the pull merge request, as well as across the CI/CD pipeline by scanning ISC templates and container images and so on. And last but not least, before we go into AI, we also want to make sure that we can detect the posture of our pipeline itself. So we want to extend it not just to the code, but also around the pipeline to detect misconfigurations, expose repositories, and be able to compare it against best practices that are known for those types of solutions. Okay, so now we covered securing the code, securing development, but now let's talk about securing AI development. So most organizations by now are using AI, and if not, they will be using in the next year or so. Our research team found that over 70% of environments have some sort of managed AI service in them today. So it's very obviously big and important for organizations to be able to secure AI to move faster. But introducing AI into the environment does introduce new types of risks. And we do hear from security teams often that while they want to enable their developers to innovate with AI, it does scare them and they do see it as a threat. So what are some of these changes that AI introduces? Obviously, now we have a new set of services. We have AI pipelines that can be complex, and security teams worry that, one, they might not even know there's this AI service used in the environment, let alone they might not have visibility into the entire AI pipeline. We also have new types of risks when it comes to AI that we need to worry for. So things like model poisoning, data leakage, model vulnerabilities, and security teams might not be equipped to detect those types of risks because they're very new and they haven't had to learn how to work with them. And then lastly, now we have AI engineers, AI researchers, data scientists working and using AI in the cloud. And those teams might not have the right skills in place in order to secure those services. So they might not be security experts, but we still want to enable them to move faster. So how can we do that? So if we take a look at a typical AI pipeline here, we can see the types of risks that can exist. So from model poisoning, where your training data can be exposed publicly and be open to the public to write to that bucket and poison your model, to model theft, to data leaks that are leaked through the model itself, or just supply chain vulnerabilities within the model technologies that it uses. So if you take a look at this pipeline, what it comes down to is context again. So in order for us to secure AI, we need to have visibility into our pipelines and understand the risks and the context around the pipeline. So we think that AI today is similar to where the cloud was 5 to 10 years ago. Everyone wants to innovate and use it, but not a lot of people know how to secure it. And that is why we are taking all the learnings we had from the cloud and securing the cloud, and we're bringing it back to AI to help organizations innovate. So what did we learn from the cloud? When it comes to securing the cloud and similarly to securing AI, visibility is the foundation. So as a security team, I need to be able to tell, hey, these are all the AI services and technologies in my environment, because visibility is obviously step number one before I can protect it. The second thing is that risk-based approach is critical, so I need to be able to detect risks within my AI pipeline. And of course, now I need to have that context around the pipeline and the attack path so I can prioritize the risks that I do find. So we did term a new kind of term for AI security, so AI-SPM, AI Security Posture Management, that includes all the capabilities that we have when it comes to securing AI. So starting off with visibility, so our AI-SPM solution, similar to the rest of Wiz, it's all agentless. So we We scan cloud environments without any agents. And now we also detect every single AI service or technology in the environment to provide security teams with visibility into what their AI engineers are doing. So whether it's a service, SDK, or anything, we will detect that. And we will provide centralized visibility for security teams so they can see quickly when there's a new service in the environment. As you can see on the right there, they can mark that service as approved or not approved based on their approved list of services. Okay, next up. So we added built-in configuration rules, so similar to CSPM checks for those familiar, that are built for AI services. So we support different types of managed AI services from Amazon Bedrock and SageMaker to OpenAI, the Azure OpenAI version, GCP version, and so on. And we support those out of the box. And we built these rules to make sure that those services are configured correctly. So for example, we look at Bedrock custom model to make sure that it is encrypted, and if it is, if it uses customer managed key or not. So essentially best practices that are built for the AI services. So let's bring it back to the attack path. So in order for us to be able to remove risks in our AI pipelines, we do need to understand attack paths around it. So we extended the deep analysis that we have across data, secrets, network exposure, vulnerabilities to AI. So now we can detect all of those within the AI pipeline. So for example, here in the screenshot, you could see a publicly exposed virtual machine that has a critical vulnerability that can access a bucket that is used for AI training. So we can see that someone could eventually reach that bucket and poison the data. Because we extend our data security to AI as well, we can help organizations detect where they have sensitive data that is used for training AI models. And we can also detect malicious models that use, for example, pickle files. Last but not least, another learning from the cloud was that we need to enable and empower different teams in the organization in order to scale the security team. So this applies back to AI. We want to empower AI engineers, data scientists to own the security of the resources that they run. So we bring everything together into a centralized location, which is the AI security dashboard, where an AI engineer can go in and quickly see what are the critical issues I need to take care of right now. So rather than overwhelming them with thousands of alerts, we take all the attack path analysis, we understand what are the critical attack paths, prioritize it for our customers, and we provide them with that centralized visibility so they can quickly go in and understand risk, see the context on the graph, so it's very easy for them to remove risk and they don't need to become security experts out of the blue. So when it comes to AI-SPM, these are the four questions that you should be asking yourself when you're looking for a solution. The first one is, do I know what AI services and technologies are in my environment? Do I have full visibility? The next one is, do I know what risks exist in my AI pipelines? And then can I prioritize the critical risks across my pipeline? And also, can I detect a misuse in my AI pipelines? So any real-time events that happen in my pipelines, can I detect them if they're suspicious? And that wraps it up for us. Thank you so much for joining us. And our booth is right there. If you turn back, you'll see it. So if you want to come see a demo of our AI-SPM capabilities or anything, we would love to chat with you. Thank you so much.